Hi students, welcome to Physics to Learn AR channel. So in previous classes we have been discussed regarding the gravitation. In gravitation, so previous concepts we have been discussed. So now in this class which we are going to discuss regarding the concept of orbital velocity. So if you have been not watched the previous videos, I am giving the links in description. So please watch it. So orbital velocity, regarding this orbital velocity we have been discussed. So for Earth, so Moon is a natural satellites, whereas other we have been taken will be having artificial satellites. How they can revolve around the Earth, so that they can revolve around that with some velocity, that velocity which you can call it as orbital velocity. Regarding this, how we can tell the definition of orbital velocity. So the velocity with which the satellite must be projected parallel to the Earth's surface after parking it in the given orbit, so that it moves around the Earth in circular orbit, is known as orbital velocity. So that which it can move in circular orbit, so with some velocity, that velocity which we can call it as orbital velocity. Just you can go through once the definition. The velocity with which a satellite must be projected parallel to the Earth's surface after parking it in a given orbit. So in which orbit it should have to move, so that it moves around the Earth in circular orbit. With how much of velocity it is moving, that one we can call it as orbital velocity. So for this, the derivation part, how we can derive our equation for orbital velocity. So this is a most important question for 3 marks or 5 marks for PUC students. So based on this, even for NCERT students also, which they can ask the derivation part as well as numericals. For this, we are considering that a satellite of mass m revolving around the planet at a height h in circular orbit from the surface of the planet. So capital M and smaller capital R are the mass and radius of the planet, so which we can be considered. So V0 is the orbital velocity of the satellite. So we know whenever you have been taking two bodies, between them there will be some gravitational force. Gravitational force of planet which you have been taken, capital F is equals to capital G into capital M into small m by r square. Here small r value which you can take it as r plus h, because it is above the surface of the Earth. From center of the Earth to the where object you have been placed, you should have to consider that as a capital R plus h. So with that we can write it as capital F is equals to capital G into capital M into small m by r plus h whole square. So whenever a body is revolving in circular orbit, so that's it's required, so which is nothing but the centripetal force. The centripetal force is nothing but F is equals to m v naught square by r. So r value is nothing but capital R plus h. So from equation 1 and 2, so what we can get? So by substituting equation 1 and 2, by comparing gravitational force of the planet which is equals to centripetal force of the planet. So in order to move a body in uniform circular motion, that it requires centripetal force. That centripetal force is equals to gravitational force of the planet. So by making substitution, which we can get it as here, which is nothing but which we can write it as, so this m and this m will get cancelled. So I need only to find v0 square. So v0 square if I have been sent toward the side. So and then here which I have been taken it as this r plus h, and then this which it can gets cancelled. So we can get it as capital G into capital M by r plus h, which we are going to get it. But we need the value of v0. V0 equals to root over capital G into capital M by R plus H, which we can be you get. If H value is very small when compared to R, under that condition, so we can write it as, so V naught is equals to root over Gm by R. So in last class we have been discussed relation between small g and capital G. You have been taken small g is equals to capital G into capital M by R square. With the help of this Gm by R, if you have been substituted, we can write it as, so which is nothing but here, so Gm value small g into R square, so which have been substituted. Finally I can get the answer as orbital velocity is nothing but V naught is equals to root over Gr, which we can get it. So regarding MCQ, so which you can get it. So the formula for orbital velocity is equals to, so just now have been proved, which is nothing but root over Gr. So thank you for watching. Have a nice day.